Hello, dear students. Today's discussion is on calculation of uncertainty. We can categorize this calculation of uncertainty in four different categories. One is addition. If two measured quantities are in the form of addition, then how to calculate their uncertainty. Then we have subtraction, then multiplication, and finally division. So these are the four categories, and one additional category is there, that what if some measured quantity is in a form of power. So these are the things that we are going to discuss right here in the calculation of uncertainty. So let's start with the first one, addition. So if two measured quantities are in a form of addition, then how to find out their uncertainty, the uncertainty of the sum. Say for an example that L1 is a length of one string and its length is 25 centimeter plus minus 0.1 centimeter. L2 is another length of the string, which is, say for an example, 55 centimeter plus minus 0.1 centimeter. So we are now going to find out the total length of the string. So what is the total length of the string? Summation of L. So this is obviously L1 plus L2 to find out the total length. So we are adding these two measured quantities. When we are just adding, we are just using their values, which is 25 and 55. So 25 plus 55 is 80 centimeter right here. This is the total length. Now when we calculated the total length, 80 centimeter, out of these two measured quantities L1 and L2, so obviously there is some uncertainty in expressing the total length also. The total length is not absolutely 80 centimeter, it does have some uncertainty. Why? Because while calculating total length, we used L1 and L2, and L1 has uncertainty of 0.1 centimeter, L2 has uncertainty of 0.1 centimeter as well. So the total length L also has some uncertainties. How to calculate that uncertainty of the length, total length? So if we want to find out the uncertainty of the total length, this is how we symbolize uncertainty of the total length. It is the uncertainty of length L1 and the uncertainty of length L2. So right here the uncertainty of length L1 is 0.1 centimeter and this also is 0.1 centimeter. So it is 0.2 centimeter. So the total length has an uncertainty of 0.2 centimeter. When we are going to express the total length with its uncertainty, we are expressing it in this way: 80 centimeter plus minus 0.2 centimeter. So see that when the length individually has 0.1 and 0.1 centimeter as its uncertainty, the total length does not have the uncertainty of 0.1, rather it is 0.2, because it has been calculated by the two measured quantities L1 and L2, and they both have uncertainty. So their uncertainties are also going to be added up in calculating the total uncertainty. So this is how we expressed the total length in terms of its uncertainty, actual uncertainty, or what we call as absolute uncertainty. So the uncertainty can be expressed in terms of the absolute uncertainty, fractional uncertainty, and percentage uncertainty. This is the absolute uncertainty. This form is representing the minus here. This form is representing the absolute uncertainty. This is absolute uncertainty. This is absolute uncertainty. When plus minus some value with a unit is given, it is in the form of absolute uncertainty. Sometimes it is also called as actual uncertainty. Now, if we want to find out the percentage uncertainty of this total length, then percentage uncertainty of this total length is its absolute uncertainty divided by its value multiplied with 100%. So it is 0.2 over 80 centimeter by centimeter. So the ratio doesn't have any unit times 100%. So it is some percentage right here. So whatever value you get right here in percent is the absolute, is the percentage uncertainty of the total length. So this is the expression, this is the formula that we use for finding the percentage uncertainty. That percentage uncertainty is absolute uncertainty divided by value multiplied with 100%. See, if the length is not given in terms of the absolute uncertainty, rather it is given in terms of the percentage uncertainty, then what to do? Right here, it is in terms of the absolute uncertainty. It is in terms of absolute uncertainty, absolute uncertainty. If it is given in terms of the percentage uncertainty, then how to find out the total length and its percentage uncertainty and the absolute uncertainty. So this is the way how to do it. Right here, say for an example, the L1 is same 25 centimeter having 5% as its percentage uncertainty. L2, when I say 5%, so there is no unit right here. L2 is 55 centimeter and it has plus minus 5% uncertainty. So the L1 and L2, they both have the percentage uncertainty to be of 5%. Now what you have to find out as what is the absolute uncertainty of L1. So from this value, you have to find out what is the absolute uncertainty of L1, which is the percentage uncertainty of L1 multiplied with the value of L1. You see the same formula right here. The percentage uncertainty is absolute uncertainty divided by value. When we subject absolute uncertainty, it is becoming the multiplication, the product between percentage uncertainty and the value. That's what we did here. Del L1, the absolute uncertainty, is the percentage uncertainty multiplied with its value. So here the percentage uncertainty is 5%. It is 5%, which is going to be multiplied with 25. So here we have 5%. That means 5 over 100. This is 25. So this is 5 over 4. So 5 over 4, which is 1.25. So it is 1.25 centimeter, the del L1 value. Similarly, what is going to be del L2? Since it is also 5%, so percentage uncertainty of del L2 multiplied with L2, it is 5% multiplied with 55. So it is 5 over 100 times 55. So how much it is going to be? 275 over 100, which is 2.75 centimeters. That is going to be L2. So when we are going to add them up to find out the total length, so this total length del L, sigma L, is 25 plus 55, which is 80 centimeter. 80 centimeter. And how much is going to be its absolute uncertainty? The absolute uncertainty of sigma L is del L1 plus del L2. And del L1 was calculated as 1.25. This is calculated as 1.75, which is going to be 4 centimeters. So del of sigma L, the absolute uncertainty of the total length is 4 centimeters. So it is 80 plus minus 4 centimeters. This is how we are expressing this value. So this is the addition part where we have calculated the absolute uncertainty and the percentage uncertainty of the total length, when they are going to be added, their absolute uncertainties are just going to be added simply. If it is not given in terms of the absolute uncertainty, rather it is given in terms of the percentage uncertainty, we have to make the absolute uncertainty from this equation, and then their absolute uncertainties are going to be just simply added up. So this is how we have to do while we are going to calculate the two quantities which are being added, and we are calculating the uncertainty of that summation, what that uncertainty it can have.